Hello, friends. This is part 2 of your podcast on Chapter 18. We're talking about probability in stats class. And when we left off, we were just taking all the information out of this problem and plugging it into this formula. So let's see if you plugged in the numbers and got the right answer. So here is the numbers from the problem plugged in. And if I did this math out, I would get 2 for a z-score. Now, you should recall from earlier in the year that the z-score tells me how many standard deviations above or below the mean this number is. So let's look at it in a graph. Here's my normal curve. Remember, this is a density curve, and the total area underneath is 1. And this is the information from the problem. The assumption, the fact about the population that was given is that the total population is 62%. And also given in the problem was a standard deviation, which was 0.015. So this distance from here to here is 0.015, as is this distance. And this one as well. So by adding that amount to that fact about that p, I can get that. The next point is 0.665, and if I add it again right here, it's 0.65. So what do they want to know? They want to know what is the area that is 65 or higher. Okay, and we gave you a table today. It should be in the back of your book, but if you didn't get it, it's here in the podcast, and it's also in these notes. And remember, you can get it on the website. So if I find the number 2.0, which is right here, this tells me that the area to the left is 97.73. In other words, 97.73%. And that means that this blue area right here has to be 1 minus 0.9773, which is 0.0227. So here's the interpretation. The probability that I would get a result this high or higher is only 2.27%, 0.0227. So it's unlikely that I would get a result this high if this statement is true. So going back to my problem, I'm just going to slide the z-score over so I can see the numbers with the calculator up. So if I go to program, you should have a program in here in your calculator. If you don't, I can give it to you, which is called z-score. And when I hit enter on z-score, it'll say program z-score, hit enter again, and now you're running. So now you're just going to type this information in. Remember to put the top in parentheses because of the order of operations. I'll get a wrong answer if I don't. So I punch this in, divided by 0.015. When I hit enter, it's going to show me the z-score, but notice the little dots are still running, so it's just waiting for you to write that down just to read it. So that's the z-score. And when I hit enter a second time, it's going to tell me this is the information I got out of my book, that the area to the left of that z-score is 0.9772, and the area to the right is 0.0228, and that means the 98th percentile. Okay, so I would expect if I did this sample, remember, a lot of times, over and over, 98% of the time, I would get a result lower than 65%. Now, on part B of this question, we're going to use that fourth probability rule, okay, because it wants to know what's the probability that it misses the truth by 1.5% or more. So misses, if I look at my graph, it wants to know if I miss by 1.5% below, which is right here, or 1.5 above, which is right here. So I'm going to have to find the area to the left on this side and to the right on this side. So why don't you pause the podcast and see if you can find these two areas and add them together. So here's what your math would look like. So you know that your z-score for to the right is going to be 1 and to the left is going to be 1. So let's just plug these z-scores into our program and see what we get. Once I'm here, if I hit enter, I go back to the beginning. So let's put a z-score of -1 in, and there it is. So the area to the left of -1 is 0.1587, and when I put 1 in, the area to the right of +1 is also 0.1587. So if I add those two numbers, in other words, 0.1587 times 2, that's the probability of being more than 1.5% away. That's it.